This is William Tomos Edwards from Bright Studies, and today I want to go over my solution to this integral. So Integrals for You on Instagram recently posted this. A lot of people found it pretty challenging, I think, based on the comments. And so, believe it or not, there's an interesting hack with integrals like these that makes them 10 times easier. I want to begin by emphasizing that what's making this integral so difficult is the fact that you have a function under a square root. Okay, you don't have a variable, you have a function under a square root. When you have a function under a square root, well, if you could use inverse trig or something in that world, well, that would be great. But when you can't, this is a terrible situation. So we go down here, and so what happens, you start getting set up for U-substitution is what's happening, right? So really that x in the numerator, the way I see that x in the numerator, it's in parentheses. Let's look at it that way. There's a lot of operations we can do on that x while maintaining equivalence and still return x in the end. So it's like, yeah, okay, minus x times -1, right? You maintain equivalence. You have that x in parentheses, do a whole bunch of operations on it, still come out equivalent. Then we come down here, right? The incredible thing about all those operations to that x in the parentheses is you maintain equivalence. It just equals x. And so now, we can clearly see what u is going to be, right? U is going to equal 1 minus x. We can clearly do that. So, and what's the derivative of 1 minus x? -1. So that's what's going on there to maintain equivalence, right? And now we go down here. Okay, great. Minus, u minus 1 squared over the square root of u. You just FOIL out that one. You just FOIL out the 1 minus u squared. FOIL it out. It's all over the square root of u. Now you just have, a plug and chug operation, an integral like that to get those antiderivatives, a straightforward plug and chug operation. So that would be how to solve an integral like that. So I just want to emphasize there's another way to go here. Symbolab actually substitutes the square root of 1 minus x. Symbolab does a substitution for the square root of 1 minus x. How is this done? By taking that x squared out of the numerator, just multiplying by 1 over the square root of 1 minus x, manipulate the equation such that the x is re-expressed as a function of the square root of 1 minus x. It just evaluates to x, do that algebraic manipulation basically, and do some algebra to make sure the 1 over the square root of 1 minus x has a 2 in the denominator, maintain equivalence, and all of that, right? So you can actually substitute the square root of 1 minus x. In my estimation, this is a way trickier U-substitution. This sets up a way more difficult problem. So I would definitely not go that way. The way I did it here, as far as I can see, is the simplest way to go. So hope you enjoyed this solution. Best of luck.